That's actually not a bad idea.
What?
Okay, we are finishing up this lesson quick. Or not this lesson, this problem for now. We'll continue this tomorrow. Okay. So it says evaluate the 6 trig functions at each real number. So at each angle. And obviously you're going to be given one that you can find on your unit circle. You're not going to get like pi over 9. Okay. It's going to be one where we can get, if you're given pi over 9, something like that, we use our calculator for. The only time they expect us to give exact answer is if it's one of these that lie somewhere on my unit circle. Okay. So, I just rate them in this order. So I start with, I'll try to color coordinate it with my chart here. I start with sine of, and put pi over 6, put the actual angle like in parentheses so I know what you're taking the sine of. Sine, cosine, and tangent, because I can just look at my unit circle for those. So this is how I start them. And then I'll tackle the other 3 after this. Okay. So somebody tell me pi over 6, give me the coordinates. Square root of 3 over 2. Perfect. So sine is just the y coordinate. So it'd be 1/2. You can test this in your calculator. Take the sine of 30 degrees. It's going to tell you 0.5. 1/2.
Crazy, isn't it?
But it's not going to give you something like this, square root of 3 over 2, because that's an irrational number. Cosine is just the x coordinate. Tangent is y over x. We already did that math. We got square root of 3 over 3 for that one. And this is in quadrant 1, so everything's positive, square root of 3 over 3. Okay, now we're just going to do all the reciprocals of these to find the other 3 trig ones. Cosecant of pi over 6 would be 2 over 1. It would just be 2. Secant, the reciprocal of cosine. Two over square root of 3.
Oh, you can do that?
Well, we have to rationalize it. Yeah, we will. So times the top and bottom by the square root of 3. I don't know why. Yes. And this one you'll get to do a lot that as soon as you like see, oh, square root of 3 over 2, the reciprocal is 2 root 3 over 3. Like you won't have to do this math too many times before you start to like recognize it. 2 root 3 over 3. Okay. And then cotangent. You could do this 2 ways. Now, technically, it's just going to be the square root of 3, right? Technically, we already rationalized it. I can show you my work here. We got this. As that value, we just rationalize it. So if you want to do the reciprocal, that's just going to be square root of 3. Otherwise, if you have to go through the work of this, you're going to get the same answer. If you don't recognize that, that's totally fine. Times the top and bottom by the square root of 3. You get 3 root 3 over 3, so it just ends up being the square root of 3. Okay, that's all that is for now. Yes?
If it were to be like pi over 9, how would we type it in the calculator?
I will show you when we get to example. Oh, there's 2 examples. When we get here. Yeah. Wait, not there. Yes, there. Wait, maybe not. It's somewhere in our notes. Oh, sorry. It's the last thing we do on the back page.
Oh, yeah.
Okay. Next one. 5 pi over 4. What is the ordered pair with 5 pi over 4? Perfect. Thank you. Is that Kaden?
Mm-hmm.
Thanks, Kaden. I know it's a pi over 4 one, so I know it's a multiple of 45, so we should automatically kind of start to like, oh, that's going to be square root of 2 over 2, square root of 2 over 2. If it helps you to, I mean, right now we're just looking at our unit circle. Think about what quadrant that would be in. All right, so the sign of 5 pi over 4 would be what? Negative square root of 2 over 2. Exactly, just the y coordinate. Cosine would be negative square root of 2 over 2 as well. The x coordinate. Tangent? Positive 1. You look, that's what we listed on the outside of that number. But that one's easy. Positive 1. All right. The reciprocal, friends. Cosecant 5 pi over 4. I'm just going to write it down here because I ran out of room. Reciprocal, and again, you might be able to do this in your head. Negative square root of 2. Yep. Good. Negative square root of 2 for that one. You need to see the algebra. Rationalize it like that. You get negative 2 root 2 over 2. So it's just negative root 2. Okay, I'm going to kind of box that one so you see that. That's for cosecant.
It would be the same for.
Yes, secant would be the exact same, right? We don't need to go through all that work again. Negative square root of 2. Last one, cotangent. What's the reciprocal of 1? 1. Okay, so you're just looking at the unit circle. Hopefully you can read your own handwriting.
Depends on the day.
Let's do a quadrantal one. Pi is negative 1, 0. We have 0 written outside of that for tangent. So, sine of pi is what?
0.
0, you betcha. Cosine of pi? Negative 1. Tangent of pi? 0. Okay. Careful on the reciprocals. Cosecant of pi is undefined. If you need to write 0 as a fraction, it would just be 0 over 1. You flip it, you're divided by 0. Secant of pi, yep, negative 1. Reciprocal of negative 1 is negative 1. Cotangent, undefined. Good. Oh my gosh. Your other option, if you're not a fan of this unit circle, I'm still going to make you memorize it for now, but your other option is just to like straight up just memorize these. Like, oh, the sine of pi over 6 is 1/2. Tangent of pi is 0. That's what
Can we make a
my teacher in high school made us do, memorize all of them. And just like,
In pre-co.
without using a unit circle.
In
Yeah,
pre-calc?
in pre-calc. Okay, let's finish up this last one and then we can stop there. Deal?
Deal.
Alrighty, so negative pi over 3, that's technically not on my unit circle. But do you guys remember?
Isn't that just negative 60 degrees?
Exactly. So it would be the same as 5 pi over 3. Okay, negative pi over 3, they're talking about 5 pi over 3. Those would be coterminal. That just means you're going to rotate this way. So it's going to end up in the same spot, meaning we're going to get the same ordered pair. Okay, so that one is 1/2 comma negative square root of 3 over 2. If you want to write down the order pair, you don't have to. 1/2 negative square root of 3 over 2. And what was tangent's negative square root of 3? Okay. So sine of negative pi over 3, actually put in the angle, is negative root 3 over 2. Cosine of negative pi over 3, positive 1/2. Tangent of negative pi over 3, negative square root of 3. Yes, sir.
This is like negative 60 degrees, right?
Yep.
Right. Why? How did you get 1/2? Wouldn't it be 3?
Did I look at the wrong one?
Wait, well, I must have wrote this in.
Uh-oh. Do you need the whiteout?
No, I'm just scribble it.
Ooh, didn't somebody else need the whiteout?
Negative.
No, I think I did that. Yeah, definitely don't write this down wrong. That would be bad.
Everybody has one.
The only time I'd probably give you the unit circle would be on the semester exam.
Please. That'd be so nice.
We did that. We did that in pre-calc and McGuire. We gave it to them on the semester exam, so I would feel fine doing that. All right. I just couldn't believe that my calc students didn't know these. I was like, we were just like solving equations. I'm like, okay, yeah. So the sine of 30 degrees, we get 1/2. And they're like, wait, I need my unit circle. I was like, what? You don't know these?
I need my unit circle.
All right, quick. Let's do the reciprocals. Cosecant. We already went through all the work of rationalizing this, right? Where? Here, yep. So it's going to be negative 2 root 3 over 3. And again, like I said, the more of these you practice, you're going to start to essentially kind of memorize them and recognize these patterns. Secant. 2. And cotangent. Good. You guys are so smart. Cotangent. Negative square root of 3 over 4.
False. Okay, my notes actually have a color on that.
Okay. Oh, whoops. So here's what we'll do. We'll finish this lesson tomorrow. Oh wait, I have a separate one. We'll finish this lesson tomorrow. We'll do a work day.